Hello everyone, this is Parinita and today we will see a home automation using IoT based project. This is an internship presentation which is submitted to Emertxe Information Technology. So let us get into it by pressing the enter button, and first we have the table of contents. The first topic is introduction, which is basically an introduction to what IoT is and the programming languages that are being used in this project. The second one is the software that is being used, which are PiximLab, Arduino IDE, Virtual Serial Port Driver, and the Blink mobile application. The third one, we see the project overview, which is the aim and requirements of the project being explained. The fourth one, and the most exciting one in my opinion, is the conclusion and the project demo. So moving into the first one, which is introduction, let us see what exactly IoT is. So basically IoT is a collection of devices connected together over the internet. These devices communicate with each other and change their internal state. They can also communicate with an external environment. A simple example is that IoT can provide over the air updates for connected cars. So the users can choose their families, their friends to automatically get messages in an event of a crash. So basically it helps connect people together and send, in this case, notifications to people. Moving on to the architecture of IoT, there are basically four components, which is device connectivity, gateway of IoT client, data analysis, and the presentation. So device connectivity is the number of devices that are connected together. The gateway IoT client helps devices that are not able to connect to the internet on their own and helps it to connect to the internet. Data analysis will help to analyze the data that is being sent from the IoT devices, and presentation is the way in which the data is presented to the people. Moving on, we see the programming languages which are used in this project, which are C and C++. C is mainly a system programming language which is mainly used in embedded software development, and C++ is a high-level object-oriented programming language which can also be used for the embedded software development purposes. So the basic structure of C language is of three parts: definition or declaration section, the main function, and the function definition section. The definition or declaration section contains all the header files and preprocessor directives which help to run the code. The main function is where the execution of the program mainly starts, and it can have a return type which is int or a non-return type which is void. The function definition section mainly tells about the functions that have to be called in the main function. Moving on, this is just a wordly explanation of the three sections. Next, reviewing the concept learned in C. The first one is data types, which are basically the type of data that C can process, which is int, float, char, double, and keywords. The conditional constructs are the conditional statements which help in checking a particular condition, which is if else, nested if, else. if, else, if, and switch. The operators and arrays is where we learned the arithmetic, relational, assignment operators, and etc. And the concept of arrays. Next, we have the pointers and functions through which we declare a variable, which is basically a pointer that points to another variable, and the different ways in which functions can be called in the main function. Next, we have the recursion and strings. Recursion is basically looping statements, which are of three types, which are for loops, while loops, and do while loops. And strings is a type of data. Lastly, we have preprocessing, storage class, and utility structure, which basically defines how C programs are compiled and executed. Next, reviewing the concepts learned in C++, where we basically learned the concept of objects and how to implement classes in the program, and the ways in which we can use constructors and destructors. Moving on to our second topic, which is the software that is being used in this project. Let us look at the PiximLab software first. PiximLab uses an Arduino Uno board, which has a microcontroller of ATmega38P. We can implement the code by loading the hex files that is generated with the Arduino IDE. Seeing the PiximLab spare parts that are being used in this project, LEs and LDRs are used for the first requirement, which is the garden lights. CLCD is used to display the conditions in which the requirements are in. Temperature system helps to cool down or raise the temperature. And the Ethernet shield will help PiximLab to connect with the Blink mobile app. Looking at PiximLab's oscilloscope is mainly used to display the waveforms of electronic signals. It basically draws a graph of the instantaneous signals as a function of time. The second software is Arduino IDE, in which we write our C code that will be executed in the PiximLab. In this project, we do not take any physical hardware. PiximLab is a software that will provide the simulated hardware for us. So we write the code in C language into the Arduino IDE and select Sketch, as you can see here, and use export compile binary to obtain the .hex files that will be implemented into the PiximLab. We use file to save the C code and give it a name. And also we need to connect the Arduino IDE to the respective board that is being used in the PiximLab. So as mentioned before, the board being used is Arduino Uno board. Next, we have the virtual serial port driver, which is mainly used to connect the system that is being used to the serial remote tank, which is provided by the PiximLab. Moving on to the last software that is being used is Blink mobile app. The software is used to control the lights, the heater and cooler systems, and the serial tank through a mobile application. So as we can see, we have the cooler button, the heater button, and a gauge widget that will help us to display the temperature. We also have the inlet valve and outlet valve of the serial tank and a gauge widget that displays the volume of this water in the cereal tank. Moving on, we have the third topic of this video, which is the project overview. Here we will see the aim and the requirements of the project. So the aim of home automation is basically to implement garden lights that will vary according to the sunlight given. We also implement the temperature system that will control the heat of the room. Obviously this is all simulated. The serial remote tank, whether it is being filled and which valve is open, and the integration of all these requirements into the Blink application. So basically we have all our home devices being integrated into the Arduino Uno board present in the Pixum lab, and the Ethernet shield that is being connected to the Arduino Uno board, which will connect it to the Blink application cloud server, and through which we receive notifications on the Blink mobile app. So basically the requirements of the home automation can be described as a cake. So the toppings are the garden lights control, in which we input an LDR sensor, which is basically the variation of the sunlight, and we get to see an output of the variation of the intensity of the LED that is being simulated as a garden light. Next, we have the temperature control system, which basically integrates cooler system, heater system, and a threshold system. We'll talk more about it later. The third one is the cereal tank, which has input and output valves, and the way in which we can control the volume of the water in the tank and display the volume on the CLCD. Lastly, we have the Blink application, which is used to create the buttons and the gauges that are being displayed on the app. So basically the requirement of garden lights is the variation of it using the LDR sensor. Then we have the requirements of the temperature system, where first we connect the heater control and cooler control to the Arduino board through the Blink IoT app. So if there is any changes, there will be a notification sent to the app, and the same will be displayed on the CLCD. The cooler system is basically if the button widget is on, the cooler system will turn on, and if it is off, the cooler system will turn off, and the same thing with the heater. The threshold temperature control is where we compare the current temperature with 35 degrees Celsius. If the temperature is more than 35 degrees, the heater button is turned off and a notification is sent to the Blink IoT app, and the same is reflected on the CLCD. Looking forward to the requirement of the cereal tank, basically it needs to read the volume of the water in the tank and send commands through serial communication. The volume of the water will be displayed on the Blink app as well as on the CLCD. The inlet valve is where through which the water is being filled into the cereal tank, and if the tank overflows, the inlet valve button is turned off, and if not, it is turned on. With outlet valve, so we send the command through the serial communication, and if the button is turned on, the volume of the water in the tank decreases. If it is turned off, the volume remains the same. So basically, the inlet and outlet valve will detect the change in the logical level of the volume of the water. The control volume of the water is where if there is volume of the water to be less than 2000 liters, then the inlet valve button will be turned on and a notification will be sent to the mobile app, Blink mobile app, and the same will be reflected on the CLCD. Next, excuse me, we see the Blink application where there are button widgets, which is basically the heater and cooler, as well as the inlet and outlet valves. The gauge widget displays the temperature and volume of the water in the tank. The terminal widget is used to display the notifications. Alright, let's move on to the most exciting part, the conclusion and project demo. Looking at the conclusion first, we saw the introduction to IoT, and next was the software and the programming languages that are being used, and lastly we saw the project overview. Alright, moving on to the project demo. So here is the Pixim lab as shown, and this is the spare parts section where all the required hardware simulators are present. Alright, first seeing the first requirement, we have the variation of the LDE. So as you can see here, if I pull down the LDR sensor, the brightness of the LED decreases, as you can see. So this LDR sensor acts like the sunlight variation, and the LED acts as the garden lights. This box right here is the Ethernet shield, which helps the Pixim lab to connect to the Blink mobile application. So as you can see, I've already run the code. So by clicking file and load hex and loading the hex file of the code, so I'll show you the code later. Alright, so when we open, so initially nothing will be displayed, and now we can see that the current temperature is 27.34 and the volume of the tank is full. So let me show you the code. Let it load. So these are the components that are present in the spare parts, and we can also see the oscilloscope, as you can see. So we are not taking oscilloscope into our project right now, we'll see this later. So here we have the serial remote tank, which has a maximum amount of water to be 3000 liters, and using the virtual serial port, we have connected it to the serial port of COM2, and here we can configure another serial port called COM1. Alright, so yes, the code is here. This is the Arduino IDE. So I am using the version as 2.10, and this is the code. First we have the Arduino file. Okay. So first we have the Arduino file, which contains all the main code of calling other functions and header files. So we have ldr.cpp and ldr.h. ldr.cpp is basically the code of the garden lights, and the .h files here all define macros which can be changed according to the user's preference. Here we have the main.h, where we have defined the pins that we have assigned to the Blink app. Then we have the cpp and .h files of serial tank. Lastly, we have the temperature.cpp and .h files for the temperature system. So this is the main code. It starts from here. So basically we have few functions that are called, and this code will help us to implement the required parts of this project. So moving on, we have discussed the variation of the garden light, as you can see here. Now looking at the temperature, let me connect my mobile application. So we are using a power mirror so that you can see my mobile screen. So this is the Blink application that is being used. So now you can see there are two tabs. The first tab is for the temperature requirement, and the second tab is for inlet and outlet valve, basically a serial tank implementation. So moving on to the temperature system implementation. Okay, now we have the basic temperature to be 27.34. Now if I turn on the heater button, as we can see, it displays heater on onto the CLCD and the temperature is rising. Now once the temperature reaches 35 degrees and above, the heater is turned off, as you can see in the CLCD, and there's a notification present on the terminal of the Blink IoT app to be saying that the temperature is above 35 degrees Celsius and we are turning off the heater. Now if I turn on the cooler button, as we can see, the temperature system starts rotating on the Pixum Lab and the cooler on notification is put on the CLCD. The minimum temperature of this Pixum Lab is set to be 27.34, so it won't go lower than this. So as you can see, it's not going lower, and I turn off the cooler button. So this is the implementation of the temperature system. Now moving on, to the serial tank. We have the inlet valve and outlet valve buttons and the gauge for the volume. Alright, so I will shift this here so that you can see the serial remote tank. Alright, so now if I turn on the outlet valve, we can see that the outflow is happening and the same is reflected on the CLCD, and the volume of the water is decreasing. Now we see that it is less than 2000 liters, and there's a notification printed that the inlet valve is turned on, and I have not turned this on, it turned on itself. And if it is more than 2000 liters, it displays the tank is full and turning off the inlet valve, and the same is being reflected on the CLCD. Let's see the demo again. So turning it on, there is a decrease in the volume of the water, and we see that it goes less than 2000 and the outlet valve is turned off, turning on the inlet valve, and the respective notifications of this process is being printed on the notification screen. Alright, so we have finished the garden lights, the temperature system, as well as the serial remote tank, and the code is here. Alright, and yeah, that's it for the project demo. It was very interesting for me as I am an ISC student and I've never worked with hardware before, and this is a very interesting project for me. I really enjoyed it, and thank you for Emertxe for giving me this opportunity, and you can contact me through my email displayed here, and everyone should actually try signing up for this because it was really hands-on and interactive, and I would recommend it to everyone. So that's all for me today, and thank you for listening to my presentation. And everyone should actually do this project. It's actually really interesting. And thank you for giving me this opportunity, Emertxe, and see you in the next one.